Gary, welcome.
Hi Rory.
You are in the new Nissan Leaf. Really excited to be driving this today.
I have to say, I'm not quite at the electric car stage yet, but this is getting pretty close to wanting to make me leap, I think. So,
Leap to a leaf.
Leap to a leaf.
Yeah. You have a future career in advertising slogans, not. I want to talk to you about what I see as a kind of change that's happening in the way IT is done in order to support business of today. And for me now, I think what I see literally in the last couple of years is that it's more and more about the data and the value of that data. Never has it been more true that each organization generates 50% more year on year.
I think you're quite right. We're in an age at the moment where things like Internet of Things is dictating that, a lot of computing is now at the edge of the network again rather than in the center, and that's now just playing into the application and the data role as well.
And I was thinking in terms of modes of transport and looking at planes, trains and automobiles, and there's a lot of talk about self-driving cars. I've barely had my foot on the accelerator at all. We've been self-driven pretty much all the way.
You didn't tell me that.
No, I didn't think it was a good idea. These cars are packing ever greater amounts of compute inside the car so that computational capability is brought closer to the thing that is at the edge of the internet, going back to your Internet of Things analogy. We know from our customers, airline customers and others, your average 787 Dreamliner has 300,000 sensors on it.
Yeah.
And that's a staggering amount of information for every flight. What we see in terms of the application of that data is the flight lands, and by bringing the data center capability, that compute capability, closer to the aeroplane, you're able to parse the data from the flight such that the maintenance engineers go around the plane, they know which bolts to tighten and which nuts to grease, etc., rather than having to do all of them on the off chance that some of them are a bit loose.
It's almost a two-layer requirement, a two-tier requirement. There is a requirement for processing of real-time data to actually keep the plane in the air, but then once that data has been collected and the plane is back on the ground again, that data can then be, if you like, transferred into, via a conventional, cloud or data center model. And then there's a whole series of additional insight that you can get from that data. But there's also, classic big data operations like working out routing information. It's not that moving this processing power close to the endpoint does away with the need for big data in the data center. It absolutely doesn't. In fact, they both mutually reinforce each other and give us the sort of levels of insight to do things and run businesses in a way that just literally was incomprehensible or indeed not even possible in previous eras or in previous models. So it's adding capability.
And I think, we talk about digital transformation. The scope of what it entails for businesses is phenomenal. The dual application immediately on the plane at the time, but also later back into the data center. I was looking up some information on how trains are using these systems. The number of sensors on a locomotive is extraordinary. And again, that dual function of the train pulls into the station, the engineers, the maintenance crew already know exactly what needs to be done and what attention is to be paid to the locomotive. But also, that information that's being collected is then transferred to the track maintenance crew to tell them that there's a weak joint 50 kilometers, 50 miles away that needs attention.
The reality is we don't even know what the applications or benefits of this are going to be in future.